So hey guys, welcome back to the fourth video in the series, the Ducky does C++ series. So today I'm going to be teaching you guys all about data types. So what are data types in C++? I mean, what are data types generally? So in programming languages, we basically write programs to manipulate data or deal with data. So our compiler or our system doesn't know what kind of data it is. Maybe if it is a number, or if it is a string, or if it is a character, or if it is of no type. If it isn't of any type, we call it void. Or if it is a true or false value, we call that boolean. So to let the system know or the computer know what kind of data we are using, or to let the compiler know what kind of data we are using, we use data types in a programming language. So let us see what are the different data types that are present in C++. Yes, there are different types present in different languages. Also, C++ allows us to create our own types. I will also show you how to do that. And it also allows us to modify existing data types. I will show you that as well in this tutorial. So let's move ahead. Okay, so you guys might remember how the structure of a C++ program looks. If not, go back to the last video and come back to this one after you've understood how the structure of a C++ program is like. So let us begin. So we all know, first we include library functions or header functions. I'm going to put in IOStream, and then we are going to be using namespace std. Now if you do not know what we are using namespace std for, I would suggest to go back to the last video if you have skipped that, because I explain everything in the last one. Okay, now opening our main function and main. All right. Now I will before declaring something, or before moving on with the explanation of or demonstration of data types in C++, I have to tell you about something called a variable. Now, what is a variable? A variable is an identifier or something that points to a memory location that has a certain value. Mainly in layman's terms, what a variable is it's just like a box, and there is something inside the box. So this variable is something that simply contains some value. So in simple language, that is what a variable is. So how do we declare a variable in C++? That is, we declare the type of the variable. Now this is where data types come into play. Now I'm going to show you the first data type that I'm going to be using here is integer, int, and I will be calling my variable number. Okay, and I'm going to set it to 0. So I have a variable number, and it contains the value 0. Consider number as a box having number written on it, and there is a value inside that box, and the value is 0. Now, what kind of value or data does that box contain? Now, that is where data types come into play. So, my box, or yes, my box number has a value 0, which is of the type integer. Now we all know, we've all studied math, integer means numbers. It could be positive or negative. I could just as easily write minus 22 here, and the compiler would still accept it. Alright, I'm going to be leaving this as 0. Now, this is integer. Now let's think for a while that what if we need decimal values? Of course, if you want to do some mathematical calculations with your program, and suppose you divide with an odd number and you get some kind of decimal value, um, how do you think will you store that? So C++ gives us the float data type to do that. We use float, and I'm going to call this variable decimal number, and I'm going to set it to 0.0. So this is the float data type. There is another called string. I'm just going to call it string, and I'm going to call it I'm going to call the variable string store. You can name your variables anything you want. So I'm going to put in a string here. This is a string. So this is how you make strings in C++. You open and close double quotes or single quotes and type in any text that you want. This is a string. Alright, we have a string now. What about individual letters or characters? So C++ has its covered there as well. We have a type called char or character. I'm going to call this variable char store is equal to for characters we use single quotes. I'm going to call this character C. I'm going to store the character C inside this variable of type character. So what these data types essentially indicate for these variables are that okay, this variable stores this particular kind of data. So these are just indicators of what kind of data is present inside those variables. Now we have true or false values. Sometimes you may run into certain situations where you need the program to return either a true value or a false value. So C++ has us covered there as well. So we have bool, which is short for boolean. Boolean essentially means true or false values, basically 1 and 0. We write true and false here, but the system just understands 0 and 1. So 0 or 1. That's essentially what it gets translated to. So I'm going to call this variable bool store is equal to, I can either set it to true or false, whatever you know is your wish. You can do that. So we have, I think these are essentially the major data types that you will be using in regular programming as well as throughout this tutorial. Now let us see how can we modify these data types. By modifying, I mean increasing the size. Now these data types all have, their they all have individual sizes. Let's say this number variable of type integer has some size. Now let me show you how you can check the size of a variable in C++. So what you do is essentially cout. You might remember from the last tutorial, cout is the inbuilt function that allows us to print data onto the screen or strings onto the screen. Now what I'm going to do is size of, and I'm going to put in the number variable. Okay, and I'm going to save this program. And in case you do not remember, in the last video I taught how to compile a C++ program as well. Just gonna compile this one, test.cpp, and there we go, it's compiled ./a.exe, and we have the size here, which is 4. Now what I want you guys to do is follow along and see out the size for every data type. I'm going to show you the size of each and every variable of the data types that I have defined up there. So let's go with decimal number now, size of decimal number, cout. Well, you can just um, copy these. Hold on. Let me make the right amount of space. So there's three more. Hold on. Okay. Cout. Now, in case you're wondering what kind of black magic I'm doing, I'm just using the Alt key and clicking on the lines so that it allows me to type on multiple lines. So what I'm gonna do here is just put the semicolon here. Now I'm gonna put in string store, char store, and we're gonna put in the last one, that is cout size of bool store. Now we are going to see how much space these variables take up in our system, or um, temporary memory. Fine, I'm gonna compile this and I'm gonna execute this. Um, okay, so I'm gonna teach you a new thing here, that is um, delimiters or escape sequences. So what I'm going to teach you right now is the new line delimiter, that is /n, or for C++ there is a shortcut called endline, ENDL. So we put endline. What this essentially does is creates like when it does output the values or the sizes, it does so after you know, putting a new line break after the value. So what that does is it prints your output in a separate line. So each of your outputs will be printed in a separate line. They will appear in a column-like manner. Alright, now let's compile this. And there you go. We have um, our integer the number variable. So int takes up 4 bytes of space. These are bytes, so they take up 4 bytes of space. Your float takes up 4 bytes of space. String, depending on the size, takes up 32 bytes of space. Your character takes up 1 byte. This also depends on the length of what I have passed in. Since there is only one character, it is taking up 1 byte, and your boolean value is taking 1 byte. So this is how much space they take. Now, as I had mentioned before, I was going to show you how we can modify the sizes of these you know, variables with various data types. Now, to modify the size, or give these variables more size or space in memory, C++ allows us to use something called double and long. Now, these only work with types that deal with numbers, so I'm only going to modify the int and float variables. So down here, I'm going to make it double, and I'm going to make this one long. Alright, so hold on, I can't make that double. I can make integer long, and I'm gonna put long twice. You can put long as many times as you want. So long is just for regular integers, but float requires double to increase its size. So double double float. Okay, so just remember long only works for your integers, and double only works for floating type. Maybe it doesn't. Um, so I'm just gonna leave that there. You can use double and long in combination only with the integer type. So I can only increase the size of the number variable. Let's compile this and run it. Now, as you can see, I have used long twice. So you can imagine this long only takes up 2 bytes of space each. So since I have called it twice, it's taking 4 bytes, and integer is 4 bytes naturally. So we are getting 8 bytes here. So this is how you can give extra space to your integer type variables. So now I'm going to teach you how to um, define your own data types. So C++ gives us this really easy way to declare our own data types, that is called this keyword is called type def. So type definition is the name of the keyword. So in short, it is type def. And I'm going to, let's say I'm measuring the depth of a swimming pool in feet. I'm going to call this feet, this data type as feet, and it is going to be of the type int. So I have, hold on. I must place this in reverse. Okay, so there we go. This is how you define custom data type. So now this feet is considered as a data type in C++. Now what is this feet? It resembles a number. So you must have commonly heard something is 5 feet tall, 6 feet tall, 7 feet tall, like that, or 5 feet deep. Uh, it's basically depth and height. So now, for intuitive purposes, or to give better meaning to the variables, suppose I have a variable named swimming pool depth, and it is 45 feet long, feet deep. Now, I'm going to declare this variable by giving it the type feet. Now, you can see it will accept this integer because I have already defined a custom data type named feet, which extends the type integer. So this feet basically accepts numbers. Now I can better understand this line of code saying that, okay, there is a variable called swimming pool depth, which is of the type feet, that is depth or height. So how many feet deep is it? 45 feet deep. You can interpret this pretty easily. So I can create another one of type feet, that is person height equal to 7 feet. Or hold on, I can make another one. It wouldn't be feet, it would be foot. Int foot. So hold on. Yes, int foot. And here we go. We have another intuitive line of code that says this person is 7 foot tall. So I guess that would be it for this video, and I will be going into strings in the next one. I'll catch you guys in the next video. So thank you. See you guys later.